Velocity time graph of a car in non-uniformly acceleration motion. Learning objective. Let us learn about uniform acceleration and non-uniform acceleration motion. Let us see a uniform acceleration in a car. A car is said to be uniformly accelerating when its velocity increases or decreases in equal amounts in equal intervals of time. Let us see a non-uniform acceleration in a car. A car is said to be non-uniformly accelerating when its velocity increases or decreases in unequal amounts in equal intervals of time. Let us plot the variable distance time graph. The distance time graph is a useful tool to visually study the motion of an object. Here in this activity, with the help of the distance time graph, we will look into various aspects of motion with non-uniform speed, that is, acceleration motion. On the distance time graph, time is represented along the horizontal axis, that is, x-axis. On the other hand, distance is represented along the vertical axis, that is, y-axis. Here, time is measured in the second, that is, s unit, and distance is measured in meter, that is, m unit. The unit meter per second, that is, m by s, is used to measure the speed of the car. At time t equals 0s, the car starts from its initial position and the initial speed is 0. Now, the slider point is moved upwards to increase the speed of the car. We can observe that at time t equals 2 seconds, the moving car travels through a distance of 1 meter. Subsequently, at times t equals 2 seconds, 4 seconds, 6 seconds, 8 seconds, 10 seconds, and 12 seconds, the car covers distances 4 meters, 9 meters, 16 meters, 25 meters, 36 meters respectively. This is shown in the table. We know that the speed of a moving object is measured as the distance traveled in a unit time interval. On the screen, you can find the mathematical formula for measuring the speed of an object. Here, in this case, in equal time intervals, the car travels through different distances. This is clearly a case of motion with non-uniform speed, that is, accelerated motion. Now, let us shift our focus to the velocity time graph for an object moving with variable speed. The rate of change of velocity of a moving object in a unit time interval is known as acceleration. The mathematical formula for measuring the acceleration of an object is mentioned on the screen. On the velocity time graph, time is represented along the horizontal axis, that is, x-axis, is measured in the seconds, that is, s unit. On the other hand, velocity is represented along the vertical axis, that is, y-axis, and is measured in meter per second, that is, m by s unit. To measure the acceleration of the car, the unit meter per second square, that is, m by s square, is used. At time t equals 0 seconds, the car at rest starts from its initial position and the initial velocity is 0. The acceleration is also 0 at time t equals 0 seconds. From the velocity time graph, we can observe that initially the acceleration of the car changes from 0 meter per second square, that is m by s square, at time t equals 0 seconds to 0.5 meter per second square, that is m by s square, at time t equals 4 seconds. The graph shows a non-linear nature during this time interval. Thereafter, the car continues moving with acceleration 0.5 meter per second square, that is m by s square, at time t equals 4 seconds to time t equals 12 seconds. During this time interval, the velocity time graph shows a linear nature. This indicates that initially, the rate of change of velocity of the car increased, but in the later part of the motion, the rate of change of velocity of the car remained constant. Learning outcome: uniform acceleration motion. Velocity increases in equal amounts in equal intervals of time. Non-uniform acceleration motion. Velocity increases in unequal amounts in equal intervals of time.